Now, on the last problem, all we had to do was find row echelon form. It's called Gaussian elimination. Now we want to use what's called Gauss-Jordan. And we want to use that, and we want to find reduced row echelon form. So in the last example, I solved the problem from here, using back substitution. But now sometimes we want to even take it a step further, and we want to be able to look directly. Z is equal to this number, Y is equal to this number, and X is equal to this number, using what we call reduced row echelon form, where all we have are zeros and ones. So let's look at how we get to reduced row echelon form. Some people prefer reduced. So now, what I want to do, I want to take row 3, and I want to multiply this by a negative 1/2. All right. Now, the reason why I want to do this, let me make this smaller, is because that's what will obtain a 1 right here. Remember, negative 1/2 times negative 2, that's what's going to give me this 1. Now, I personally like to use just reduce row echelon form. I'm sorry, row echelon form, and use back substitution. But there are some times where this method is beneficial. Now you can see I'm basically divided everything through by 2. So I'm almost there because I've obtained this third row how I wanted it. Now what I need to do, I need to make this 1 into a 0. All right, so a lot more steps in this method. Right, so this is what I'm going to do in this case. I'm going to say negative 1, row 3, plus row 2. That's going to give me a new row 2. All right. We leave this row alone, of course. Now, 0. This is going to be a negative 3. And now, negative 1, row 3. That's negative 1 times 1 gives us negative 1 plus 0. That gives us that 0 that we would like, but we have to go the old way. Negative 1 times negative 2 gives us 2. And 2 plus negative 11 gives us that negative 9. So we're almost there. 0, 0, 1, and negative 2. All right. Now, the next thing we want to do, we want to make this negative 3 sitting there in the middle. We want to make this into a 1. Okay, and how will we do that? I'm going to say negative 1/3. I'm going to say negative 1/3 times row 2. Give me a new row 2. Okay, let's come back to it. Remember, we're not bothering. We only change the row that we're working with. Now, 1/3 times 0 is 0. 1/3 times negative 3. Negative 1/3 times this is going to give us 1. Negative 1/3 times 0 gives us 0. And negative 1/3 times negative 9 gives us a 3, 0, 0, 1, and then a -2, okay? We can kind of see this problem starting to unlock for us a little bit. Yeah, we're just taking our time. All right. Now, the next thing that we want to do, uh, the next thing that we want to do, we want to make this number into a 0 and this number into a 0. So what will we do in this case? Now, remember, this is not unique, so you may choose a different route to get to these same results, and that's fine. But what I would do, I would say -1, row 3 plus row 1. That's just going to give us a row 1. We come back to it. -1 times 0, that's still a 1. This is still a 1. -1 times 1 is -1, plus this gives us a 0. And -1 times -2 is 2. This gives us a 4. Okay. And now, as we can see, we're just getting closer and closer and closer to solving this problem and working everything out for us. And like I said, these take a lot of repetition just to get the process down. All right. So the next thing we want to do, we want to make this into a 0. How would I do that? I would say -1, row 2 plus row 1, and that's going to give us a new row 1. Okay, let's do it, and this is going to close us out. -1 row 2. -1 times 0 is 0, and then this gives us a 1. -1 times 1 is -1. This gives us a 0. -1 times 0, this gives us a 0. -1 times 3 is -3 plus 4. That gives us a 1. All right. And now, once we do this one, we pretty much are able to solve it. So now we can see we don't have to go through the algebra process. Now this is in reduced row echelon form. And the difference, remember, we have a coefficient matrix filled with nothing but ones and zeros. So here, all we have to say is z is equal to -2. We can move up, y is equal to 3, and x is equal to 1. So it's the same answer, of course. It's the same answer, the same result as the last one. Of course, it's the same system, but here we just put a different approach on it. So this is how we use Gauss-Jordan elimination and with reduced row echelon form.